Alright, so this is going to be the third method for finding GCF. This one has kind of a funny name. Call it upside down half birthday cake. I'm just going to put cake method. And we'll see why that is. It's really just a name to remember it. But what we're going to do is we're going to think of our factors. We're going to use the same numbers to find the GCF. So let's say we had 18 and we had 24. We wanted to find the GCF, the greatest common factor that these both have in common. I'm going to follow my steps that I have written down. Okay, it's going to be on the back of your notes today. So the first step was write the numbers in the first layer of the cake. So remember, my cake is upside down. So I would have 18 and 24, and I'm going to draw like a little layer right there over it. It looks kind of like an L right now. And I'm going to say, what's the smallest prime number that's a factor of both numbers? So what's the smallest prime number I can divide both these by? And I remember my first few prime numbers, 2, 3, 5, 7. So I'm going to start with 2. Can I divide them both by 2? Yes, I can. So I put my 2 on the outside. Step 2, then I'm going to divide by that factor. This is step 3. So 18 divided by 2 is 9. I put that right underneath. 24 divided by 2 is 12. I put that right underneath. Now I'm going to think, can I divide by any more prime numbers? 2. Cannot divide by 2. Can I divide by 3? Yes, I can divide both of those by 3. So I'm going to draw another layer over it. Put my 3 on the outside. 9 divided by 3 gives me 3. 12 divided by 3 gives me 4. And I think, can I divide this by anything else? No, I can't. Okay, so I've factored out as much as I can from both of these numbers. Now the reason why we call it upside down cake, if you imagine like a tiered cake, sort of like half of a cake, these are the layers of our birthday cake, these would be like our candles on top. That's where it comes from. And I'm going to take these and I'm going to say, move on to step 4, circle the numbers on the left side and multiply them together. So not these numbers on the bottom, but just what's on the left. I'm going to circle those, and I just have to multiply those two things. 2 times 3 equals 6, or my GCF equals 6. So this method works because what we're doing is we're just looking at what can we factor out of both numbers, and if we factor it in pieces, that's okay. If we factor it as one big number of 6, that's okay, but when we break it down slowly, we can see 2 and 3 can both be factored out. 2 times 3 is going to give us 6. So write the numbers, factor out what you can with small numbers, draw a line. If you can still keep factoring, do so. Draw a line. When you can't factor anymore, you stop, circle the numbers on the left, multiply them together, and that's your GCF. This also can work with 3 numbers. So if I had, like my last example, 18, 24, and I did 8 last time, but let's do 12, just to make it a little different. I could draw my line and think, what can I divide them all by? 2 would give me 9, 12, and 6. And then I would look at this and I'd say, okay, can I divide them by anything else? I can divide them by 3. Can't do 2, but I can do 3. So this would give me 3, 4, and 2. 2 times 3, 6. So my GCF for these 3 numbers also equals 6. Okay, you want to be careful because you might see that you get to this point where 2 of the numbers can still have a factor, but unless it works for all 3, you got to stop right there when you're doing GCF. Alright, so that is using method 3, or upside down half birthday cake method.